Good morning. Now we have the final election of this course in this term, and the theme of our lecture is the inverse lattice or the reciprocal lattice. What is it, the inverse or reciprocal lattice? Each crystal structure is corresponded by a lattice. The straight crystal lattice described above, and the reciprocal or inverse lattice, which is constructed as follows. The first condition, if the usual direct lattice is constructed on the transplantation vector ABC, then the axis of the inverse lattice A star, B star, C star are defined as a vector products. You can see here. And the second condition, the actual parameters of the inverse lattice A star, B star, C star are equal to the inverse values of the interplanar distances of the flat grids of the grid normal to this axis. Here you can see straight lattice and inverse lattice. To each plane H, K, L on the lattice line, there corresponds in the reciprocal lattice the side H, K, L. An infinite family of points H, K, L star in the space of the inverse lattice corresponds to the infinite family of parallel planes H, K, L in the space of the lattice toroid line along the direction normal to these planes. The distance of these points from the point taken as the origin in the inverse space are 1 derived D, 2 derived D, 3 derived D, where D is the distance between the planes H, K, L. It's clear that if A is equal B multiplies C, the vector R star is normal to the plane of the vectors B and C. The three vectors A star, B star, C star are chosen so that they, like A, B, C, make up the right three. The vector A star, B star, C star are the areas of elementary parallelograms in the coordinate planes of the direct lattice. Their absolute value is inversely proportional to the interplanar distances of the direct lattice. The order of recording the lattice. Please look here how to write vector A star, B star, C star. In the denominator is mixed product of vectors. The direct and inverse lattice are conjugate, that is, the lattice constructed on the axis ABC is inverse to the lattice A star, B star, C star, and the lattice constructed on these vectors is inverse to the lattice A, B, C. The basic properties of the inverse lattice. The inverse lattice vector is perpendicular to the plane HKL or the direct lattice. The length of this vector is equal to the inverse of the distance d between the planes HKL of the direct lattice. and you can write vector h the next way. The volume of the unit cell of the inverse lattice is equal to the inverse of the volume V of the unit cell of the direct lattice, and you can write or define by the next way. On this slide you can hear the relationship between the parameters of the forward and backward lattice. Look please. The same please. And of course you have a question, what for? Why do you need the inverse lattice? The concept of the inverse lattice is introduced to describe the periodic distribution of the reflectivity of a crystal with respect to X-rays. And at the end, and for the best comprehension of this theme, I want to show you the short film about the inverse lattice. Look please.